Let me just share my screen real quick. Okay, so before I will start our discussion for the module 5, so any question or clarification so far regarding the discussion last meeting or any concerns regarding with the new module today? Well, I'm pretty sure you guys have already saw the module, yeah, the week 5, module 5 tab. So again, as usual, you guys have a lot of quiz to do. Well, don't you guys worry, they are super easy anyway. All right, so if you guys don't have a question anymore, so let me just check if you guys are already in front of your computer. So just give me a thumbs up. So to those who are, whom I can see their faces, so it's okay already. To those their cameras are off, so please give me thumbs up so that I would know that you are already ready. Okay, great. So most of you are already here. Okay, so module 5 is statistics. So let me start with the question. Have you guys already learned about statistics before? Anyone who has taught maybe the basics? Or this is your first time? Anyone? Just maybe give me thumbs up if you already have an idea about statistics. Okay, there's 1, 2, 3,
A
4.
tiny bit. I don't remember much though.
Yeah, okay, that's fine. Okay, Mr. Fardo. So there were 7 or 8 who already know probably. So with this module, so this is just like a review. Okay, since you guys already learned the basics. So the only thing that I will teach in here are just the basics, and not the super hard statistics that you guys are hearing about. Anyway, so let's start with the definition of statistics. So this is a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data. Okay, and you can just simply say it's a collection of quantitative data. Okay, so mostly if you're talking about statistics, so there is always a data, and then what is the data? Of course, it's numerical or quantitative. Okay, so we should be able to count that one, or we should be able to see uh, the number itself. Okay, all right. We have two types of statistics. So we have the descriptive and then the inferential statistics. So we could see that for the descriptive statistic, so this is the first step you can do. Okay. So this one involves the collection. So you collect first, you organize it, and then you summarize it, and then you can now present that data with an organized, data or arrangement. And then the last one or the second one is the inferential statistics. So this is now where we interpret that data that we've just collected, we've organized, and that we've summarized. Okay, so we could say that this is where we draw a certain conclusion. Okay, so you can say that this is not two types, but they are like most likely, connected with each other because we do this one first before we do this inferential statistic. Okay, so we need a certain data before we can interpret that one. Like in here, we can have a raw data, okay, like a fresh data, so like no data at all. So you have to collect that one first, organize, and then summarize. And then after that, you can interpret and then draw some sort of conclusion. All right, so let's start with the basics on how to solve a descriptive statistic. So of course we collect first, so on and so forth. But in here, of course, there's already a given data. So the collecting part is already done for you guys. So organization, will be having this kind of statistic later on. So we'll talk about frequency distribution. Okay. Anyway, so under measures of central tendency, we have 4 types. So all in all, we're just talking about average right here. Okay. So when you see average, so it's already the mean. Okay. Or you can just see the median or the mode or the weighted middle. Actually, all of them talks about the average. So they just have their own ways on how to solve or how to find their average. Okay, so let's start with the arithmetic mean. So this is the most common one, and this is the most reliable average. Okay, unlike the others, they are quite sensitive or not that sensitive. But in here, this is the best one for me. Okay, so the arithmetic mean is the most commonly used measure of central tendency. Okay, this is the famous one actually. Even though this one haven't taught you guys, maybe you are already using this one in your in your daily lives. Okay, so the arithmetic mean of a set of numbers is often referred to as simply the mean, okay, or just mean. To find the mean for a set of data, find the sum of the data values and divide by the number of data values. So this is, our common ways to find, an average, a common mean. So for instance, we have these data. To find the mean of the salaries listed below. Okay, so we have this first salary, second salary, third salary, fourth, and then fifth salary. So my bad, there is a typo right here. There should be a dollar sign with this 44,000 also. Anyway, so it says here that find the sum of the data values. So all you need to do is add everything and divide by the number of data values. So meaning we have to count how many data we have, okay, or how many data we have just added. So just add everything and then divide it one by one, two, three, four, and then five. Okay, the counts of the data that we have in here. So here is the solution. So whatever is the result of that one, just divide it to five, and then you will get 41,300 as the average, okay, or as a mean of these salaries. Well, I'm pretty sure you guys already know how to do this one since most of us have already done this one many times. Okay, so we call that one the arithmetic mean. So this is just the technical term for that one. Okay, but when we were in elementary or high school, we call this one just average, right? Just by adding the data and then divide it with the counts of data. So are we clear so far regarding with this one? Well, everything is super basic for now. So here is the technical explanation of arithmetic mean. So the traditional symbol used to indicate the summation is the Greek letter sigma. Okay, so this is the indicator to indicate that this is the summation of your datas. Okay, so thus the notation summation x, called the summation notation, denotes the sum of all the numbers in a given set. Okay, so just add everything. Okay, meaning it's a summation of all of your datas. Then we can define the mean using summation notation by this one. Okay, and then just count how many datas we have. So it's being represented by n. Okay, so depending on the counts of your datas right here, that would be the number of your n right here. So statisticians often collect data from small portions of a large group in order to determine information about the group. So that's the common thing about is statisticians, of course. The certain group, they need to divide that group maybe, and then just get the data that they wanted, and then they can now do anything that they can do, whatever they can do to that data, so they can get it. Maybe the average, the deviation maybe. So there's a lot of things that they can do. So the others, it's up to them now. So in such situations, the entire group under consideration is known as the population. And any subset of the population is called a sample. So it is a traditional to denote the mean of a sample by X bar. Okay. And then to denote the mean of a population by the Greek letter U or mu. Okay. So this one is for the sample itself, and then this one is for the mean of the population itself. So here, don't get confused with this term population. This doesn't talks about the population of the people, okay, here on Earth or here in the Philippines. So this one talks about the group itself. You know. So let's have a short representation of what is this population. So let's say in a classroom. Okay, this is a classroom, and then let's just see that we have here a total of 50 people. Okay, or let's just say 50 students. Why is it lagging? 50 students. There you go. So we have 50 students right here. And then let's just see that this is, one subject with 50 students. And then as we all know, let's say that it's a mix of students. So some are civil engineering, some are computer engineering, some are electronics communication engineering. Okay, so in this class, we have CPEs and let's say ECE. Naglalag talaga. Ewan ko kung ano nangyari sa PC ko. CPE, ECE, and then we have here CE. Okay, so let's just see that there are three different courses in this class. So if you want to get the list of CPEs, let's just say that there are 15 CPEs, maybe there are 25 CPEs, and then there are 10 CEs. So the one that we're talking here now is the sample that came from the 50 students of this class. Okay, so when we say population, it is the entirety, okay, of a certain group. Okay, so it is the count of that or the total counts of people, or let's say a thing, okay, not just people, could be thing also, okay, or an object on that certain group. Okay, and then the let's say the division of that population are called now the sample. Okay, so this is a sample that came from this population. This is a sample that came from this population, and this is the sample that came from this population. Okay. So I hope we're clear with this one. So a sample is a subset of a population. Okay. So going back here, so for the sample, we have here X bar. And then for the population, we have here mu. Okay, talking about the entirety of that certain group. Okay, so let's have more examples. Well, find the mean of the 6 friends in the biology class of 20 students received test grades of 92, 84, 65, 76, 88, and 90. Now, as you guys can see right here, this is the total count of the students. Okay, we have 20 students, but we are only getting, the average of those 6 friends in a biology. Okay, so we have 92 and so on and so forth. So meaning this one now is a sample that came from this population. Okay, so the same scenarios, just add everything. Okay, so we have 1, 2, 3, 4, 5, 6. So the count of data we have in here is 6. So just divide it into 6 and then just compute that one using your calculator, and then you will get 495, my bad, 82.5. Okay, so 420 came from Mr. Dennis. He said, I'm a I don't know. So maybe he just calculated that one using his mind. So the answer is 495, and then divided the one by 6, you will get 82.5 as the average or as the mean of this one. And since this one is a sample, so you have to use X bar. Okay, so don't use mu because this is not the population or the entirety of that certain group. So this one is just the part of that population. Okay, so are we clear so far regarding with this example? Well, you can just verify this one later on. Okay, so as long as you guys are getting the idea, then it's already fine. So are we clear so far about sample, population, and then the mean, and
Yes,
then the
sir.
the X bar, and then the mu, those things. All right, so let's now proceed to the median. So that's already it for the arithmetic mean. So let's now talk about the median. So this is another way, another type of doing or getting the average. So essentially, the median is the middle number. Okay, from the word itself, median. So that's why it's called median, because we are getting the middle part or the middle number or the mean of the two middle numbers in a list of numbers that have been arranged in numerical order from smallest to largest or largest to smallest. So either of those two, they are just the same. So any list of numbers that is arranged in numerical order from smallest to largest or largest to smallest is a rank list. So we call that one a rank list. So in here, we have two steps. we have to arrange that one first into a rank list. So it could be from smallest to largest or largest to smallest. So either of those two, it's fine. Okay. So in here, in arithmetic mean, you only have one, you know, step, and then you will get the result as soon as possible. But in here, we have two steps. We have to arrange that one into a rank list, and then we have to decide, or we have to check if that is, or if it's a odd, okay, or if it's an even. So what I mean by odd or even, so it is the count of data that we have in that let's say a group. So the problem in here is what if we have 900 plus datas. So are you willing to count it one by one just to check if it's uh, if it's odd or even? So that is the hard thing with the median. Well, if you're going to do that one manually, it's really a pain in ass. But I think there's a lot of applications that will let you arrange that one from top, from smallest to largest, and then it will identify if the total counts of numbers are odd or even. So with that, it will make your life easier. Okay. Anyway, so yeah, so in solving the median, okay, so just rank that one into a rank list, and then you can just simply get the middle number if the n is odd. Okay, if we have an odd counts of datas, and then we have to get the mean of the two middle numbers if the n is even. Okay, so are we clear with that one so far? Okay, so very straightforward. Let's have an example. So find the median of the data in the following list. So in here, we only have 1, 2, 3, 4, 5, 6, 7 datas. So very quick to see what is the median in here. And then the number 2 is 1, 2, 3, 4, 5, 6. Okay, so it's already obvious. So if it's odd, you can just get the middle one. But of course, you have to arrange this one first. But for the number 2, of course, you have to get the two middle numbers, since we have an even count of datas in here. So here is the solution. So in arranging this one, we'll have 1 for 8, 9, 12, 14, 21. So as you guys can see, this one is arranged from smallest to largest, or you can do the other way around, largest to smallest, so it's fine. And then in here, you will get 9 as your middle number. So this is already the median for the number 1. Okay. And then for the number 2, so in here, we have accounts of even numbers, okay, for the accounts of data. So in here we have, uh, well, you can just disregard those two, okay. But in here, so we have to get the two middle numbers, which is the 77 and 89. And then we have to add those and then get the mean of those two numbers. So 77 plus 89 divided by 2. Oops, wala ba akong sagot dito ay solution. Right, so I don't have the solution in here, but yeah, 77 plus 89 divided by 2, okay, it will give you a result of 83. So this is now the median, okay, that was solved from these two numbers. So it is also possible that the median is not around or is not on this list of datas. So you can come up with new median, okay, because we have an even counts of datas in here. So are we clear with the median? So just respond as fast as you can, guys, so that I'm let's say how do you call that one? How do you call that one in English? Like napaniwala nyo ako. So you guys can persuade me that,
Convince me, sir.
yeah, convince, not persuade. Oh, so you guys can convince me that you guys were able to get what I'm trying to say here. Okay. All right. So let's now move on to the mode. So that's already two. So very easy. So the mode is also a very easy way of doing the average. So this is the third type. So the mode of a list of numbers is the number that occurs most frequently. So in here, this is another problem, since What if again we have 900, 5,000 datas, and then you need to check that one by one. All you need to do in the mode is find the data that occurs the most. So again, it would be a pain in ass if you have 5,000 datas, 10,000 datas, even 20,000 datas. Okay, if you're going to do that one manually. But then again, I think there's a lot of applications out there that all you need to do is copy and paste those datas that you have uh, accumulated, and then it will do the computation already in just one click. So some lists of numbers, of course, do not have a mode, so that's possible. So for instance, in the list of 1, 6, 8, 10, and so on and so forth, each number occurs exactly once only. So because no number occurs more often than the other numbers, so there is no mode on this particular example. Okay, so that is also possible, and it is also possible that we can have more than one mode. Okay, we can have two, we can have three, four, five, or even 10, or even 100. Okay, so for instance, in the list of 4, 2, and so on and so forth, okay, you can just check this one later on. Number 2 occurs 3 times, and number 9 occurs 3 times also. So with that, we have 3 the same counts of datas in one group. So each of the numbers occurs less than 3 times. So this is for the others. Thus, 2 and 9 are both modes for the data. So in here, we have 2 average, which is the 2 and 9. Okay. So in here, this one is not reliable anymore since, as you guys can see, it is quite far already, having a 2 and 9. So what is the meaning of that 2 and 9? It's just that the number that occurs the most. Okay, so that is why the mode is rarely used. Compared to median, so median is a little bit more reliable when it comes to getting the average. But when it comes to maybe most frequent data, maybe this is where you can use getting the average, or the average. Okay, so the most frequent data that appear. So let's have an example for this one. So we have number 1, which is 18, 15, 21, 16, and so on and so forth. And then for the number 2, we have 2, 5, 8, 9, 11, 4, 7, 23. So let's proceed to the solution, since, you can just check this one after our discussion. So in this list, okay, the number 15 occurs more than the other numbers. So we could say that number 15 is our mode in here. Okay, and then for the number 2, all of them occurs only once. Okay, so because no number occurs more often than the other, so there is no mode for this number 2. So again, this is just to show to you that that is how to find the mode, and it's also possible that there is no mode. Okay, so are we clear so far with the mode?
Yes, sir.
Sir.
All right, so those are the basics of getting the average. Okay, so as a conclusion, the mean, the median, and the mode are all averages. However, they are generally not equal. So the mean of a set of data is the most sensitive. Okay, so a change in any of the numbers changes the mean, and the mean can be changed drastically by changing an extreme value. So that is why in my case, this is the most reliable get it, or in getting the average. So in contrast, the median and the mode of a set of data are usually not changed by changing an extreme value. Okay, so as you guys can see, based on our examples, that is what happened in our median and the mode. So we can just neglect the first two datas, and then the last datas with the median, so it won't affect our average. Okay, so the same with the mode. So when a data set has one or more extreme values that are very different from the majority of data values, the mean will not necessarily be a good indicator of an average value. Okay. So to compare this one, we have this example right here. So in the following example, we compare the mean, median, and the mode for the salaries of 5 employees of a small company. Okay, so we have $370,000, 60,000, 36, and so on and so forth. Okay, so here is the solution for each of those. So we have the mean right here. So you just simply need to add everything and then divide that one by the counts of data that we have in here. So we will get 101,200 as our average. But for the median, okay, all you need to do is, of course, again, arrange this one from smallest to largest, and then the middle number is $36,000. So this is already our average for the median. And then for the mode, so 20,000 appear more than the others. So our average in here is 20,000. Okay. Now, as you guys can see, most of the data, or most of the employees rather of this company would probably agree that the median of 36,000 is better representing the average of the salaries than does either the mean or the mode. Okay, well, in fact, this one is actually like the best one. Okay, if you're going to add everything with this extreme volume, okay, over 20,000. Okay, so they agree that this is the fair computation of the average of those 5 people, which is $36,000. So as you guys can see, there's a lot of issues if you're going to compare each of those. So yeah, they have their own advantages and disadvantages. Okay. So are we clear with this comparison of mean, median, and mode?
Sir.
Bago ka
Yes,
ng
sir.
profile pic, I mean, ng virtual background, Mr. Balboa. Iingit ako. Kala ko pa man din may chicks ka sa likod mo. Anyway, so let's now proceed to the weighted mean. So this is now the the advanced way of computing the average of is written data. Okay, so this one still came from the mean itself. So you guys can see we have this similar computation, but in here we are now considering the weight of that certain data. So a value called the weighted mean is often used when some data values are more important than the others. Okay, so for instance, many professors determine a student's course grade from the student's quizzes and the examination. Consider the situation in which a professor counts the examination score as 2 quizzes scores. So meaning it's like 1:2. So 1 point for the quizzes and then 2 points for the exams. So we could say that, yeah, exam is really, more important than the others. So it's like, already 50% because in UC it's already 50%. Okay, and then the rest are, let's say, 10% for the sit works, and then 40% maybe for the quizzes. So that depends on the instructor itself. Okay, so to find the weighted mean of the students' scores, the professor first assign each of the quiz scores a weight of 1 and the exam score a weight of 2. Okay, so a student with quiz scores of 65, 70, and then 75, of course, you have a lot of quizzes, but you're only going to have one exam. So, and this exam right here, or his exam has a score of 90 and has a weighted mean of this competition. Now, if you guys are going to complete this one, it's super easy. All you need to do is multiply this data to its equivalent weight. So for the quiz, it's equal to 1. And then for the exam, it's equal to 2. So just multiply its, to its uh, um, like relative or partner weight. Okay, so in here we have 65 times 1, 70 times 1, 75 times 1, and then for the exam, we have 90 times 2. So in here, how do we identify the counts of data? So all you need to do is, ano ba to? Like, yeah, you can count them one by one, but you have to consider the weight at the same time. So in here, we have 1, okay, 2, and then 3 because the weight of those quizzes is 1. But in here, okay, you don't count this one as 1 anymore because the weight of this one is 2. So you're going to count this one as 2 itself. So that's why we have 1, 2, and 3, and then 4, and then 5. Okay, so that is why we have 5, or it's divided into 5, though we only have 4 counts of datas. Okay, so we've now considered the weight of each of those scores. So just, you know, uh, use your calculator and then just solve this one, and then you will get 390, and then divided 1 by 5. And then this student get an average of 70. Okay. So note that the numerator of the weighted mean above is the sum of the products of each test score and its corresponding weight. And then the number 5, which is the denominator, is the sum of all weights, which is the 1 plus 1 plus 1, and then plus 2. Okay, so all you need to do is uh, count the data that you have in here and then their equivalent weight. Okay, that is a 1, 1, 1. And then we have one data in here and its weight also. Okay, which is 2. So that's why it's equal to 5. So are we clear so far with this example or with the idea itself of the weighted mean? All right. So let's now proceed to the technical explanation of the weighted mean itself. So here is the main formula, okay, of the weighted mean. And before that, so the procedure for defining the weighted mean can be generalized as follows. So the weighted mean of the n numbers x of 1, x of 2, x of 3, up to x of n, with the respective assigned weights, which is weight 1, weight 2, weight 3, and so on and so forth. Okay, so all you need to do is multiply that one to its corresponding weight. Okay, so that is why we have here summation of your data multiplied to its corresponding weight. Okay. And then all you need to do is divide that one to the summation of weight that we have in here, where the summation of x times w is the sum of the products formed by multiplying each number by its assigned weight, and then the summation of w is the sum of all weights. Well, this is just the notion, okay, of those symbols and then letters in here. Okay. Anyway, so we don't have enough time anymore, so we will just continue this example on the weighted mean on the part 2 so that we can have a good start on the part 2. So goodbye for now, and then see you guys later, okay, on the part 2.
Bye, sir.
Goodbye.
Bye, sir.
Goodbye. All right, so hello again and good afternoon. So let me just check if everybody is already here, so just give me thumbs up. Right? So it seems that half of you were already here, more than half of you, like 70% maybe. There are others who are not responding anyway. So I hope they'll be back right away. All right, so let's answer this one now. The example on the weighted mean. So many colleges use the 4-point grading system. So in my case, I've never experienced this one. Okay. My school before, elementary, high school, even of course in UCD, we don't use this one. Okay, so I've never experienced this kind of a 4-point grading system. So anyone here who who've experienced maybe this kind of grading system like uno, dos, you're saying uno is I don't know, maybe the passing grade. So as long as you will get uno, then it's right, okay. And then cuatro, I don't know, but it seems like this one is the opposite, since uno in other schools are, the 95 or the, like, the high score, the high grade, right?
Yes,
Am I
sir.
correct in that one? But in here, uno is like maybe 75, and then dos is maybe 80, and so on and so forth. And then if you have a grade of A, then that one is like maybe 95. Okay. Anyway, so a student's grade point average, or GPA, is calculated as a weighted mean, okay, where the student's grade in each course is given a weight equal to the number of units or credits of that course is worth. So the question here is find the weighted mean. So the table below shows the LUN's fall semester course grades. So use the weighted mean formula to find the LUN's GPA for the fall semester. So here is the course, and then here is the corresponding course grade, and then the course units. So in this school, English subject is a total of 4 units. History is history. Chemistry is history, and then algebra is 4. So it says here that the weight this is one is coming from the course units itself. So the higher the unit of that course, the more that it's more important for you to have a high grade on that one. Okay, so in here, English and algebra is a lot, better, or at least 1 point better with the history and then the chemistry. Okay, and then here are the corresponding course grade of the LUN. Okay, for the English, I was able to get a B grade. Okay, and then we have here history, which is A, chemistry is D, and then algebra is C. So I don't know. In some schools, they even have like A plus, A minus, B plus, B minus, etc. etc. Okay. So in here, let's just focus with the letter itself, which is just A, B, C, and then D, and even F, of course, for the failing grade. So here is the computation. So this is the explanation on the B is worth 3 points, and so on and so forth. But yeah, all you need to do is use this formula, okay, and then you will have this one as your solution. So for the weighted mean, we have 3 times 4 because letter B is equal to 3, and then 4 times 3 because A is equal to 4, okay, and then it's equal to 3 units, plus 1 times 3 because he has a grade of D, okay, on that chemistry, and then 2 times 4 for the algebra because he has a grade of C, okay, and then multiply to the course units. And then you can just divide this one with the total counts of weights that we have in here. So we have 4, 3, 3, and then 4. So 4 plus 4 is 8, plus 6 is equal to 40. Okay, so here are the data that we have 3, 4, 1, and 2, which came from this course grade, and then followed by the course units or the weight itself. So just do the math, and then you will get 2.5 as your weighted mean. And I don't know, maybe this one is equal to C plus or B minus. So the LUN's GPA for the full semester is 2.5. All right, so just let me know once you're already good with this one, once you fully understand everything. So we can now proceed to the next slide. Okay, very good. 1, 2, 3.
Okay, po, sir.
Okay, very good. 1, 2, 3, 4, 5, 6. Like 6 out of 27. Okay, or 9 or 10 out of 27. Still not good, since I at least need 13. If you guys were able to convince me that most of you were able to get this one, then we can now proceed to the next one, because it's a bad news if you didn't get this part. So I want you guys to to learn, I mean, to understand everything, not learn everything, because you will learn everything. Just be familiar, right? Be familiar. So there are times that this might be helpful in your job, maybe. Anyway, so that's it for the weighted mean. So let's now proceed to the frequency distribution. So in here, this is the like the reality. Okay, so this is what you do first before you can have this kinds of datas. So this one is only for one person. But what if you have uh 10 students, 20 students? So you will have a table which is called the raw data. So raw data is from the name itself. So it is a data that have not been organized or manipulated in any manner are called raw data. Okay, so let's just have this example. So this is already a lot actually, like 5, 10, 15, 20, 25, 30, 35. Yeah, we have 40 datas in this table. So a large collection of raw data may not provide much readily observable information. Well, maybe you can get the mode of this one. Okay, I think maybe the mode of this one is 1. Okay, but after that you cannot do anything anymore. Okay, because you have to no, if you're going to get the median, so you're going to arrange this one. If you're going to get the mean, you also need to add everything and then count how many data. So that's quite you know uh, a pain in the ass to do that one. So in here, uh let me introduce to you guys the frequency distribution. So this is a table, list observed events and the frequency occurrence of each observed event is often used organized raw data. So for instance, consider the following table, which is the list of number of laptop computers owned by families in each of 40 homes in a subdivision. So from this raw data, okay, to make your life easier, okay, so we have to make this one or put this one into a frequency distribution. So this one is the example of a frequency distribution. So here we have the observed event number of laptop computers, which let's just call this one as your X. And then we have here a frequency number of household. Let's just see, this is the frequency, okay, on how many times it appears on this first column, okay, with X laptop computers. All right. So in here we have 0 to 7, okay, and then we have random numbers here, which the count of datas of those x right here are the numbers right here. So this row indicates that there are 14 households with 2 laptop computers, and then we have one. Okay, so my answer is incorrect. So see, the median in here, I mean the mode in here is not 1, but it's 2 because 2 appeared more, than the 1. So okay. So yeah. So for 0 computers, we have 5 household for that one. Okay, for 1 computer, we have 12 household for that one. And then we have 2 for 14, 3 for 3, 4 for 2, and so on and so forth. Okay. So the formula for a weighted mean can be used to find the mean of the data in a frequency distribution. So the only change is that the weights like W1, W2, and so on and so forth are replaced with frequencies, which is F1, F2, and so on and so forth. Okay. So this procedure is illustrated in the next example. Okay. But yeah, so are we clear so far regarding with this frequency distribution? There is actually one thing that
Yes, sir.
is missing. So as you guys can see right here, if you guys are going to observe this one, there is no 6 in here, right? But we still included that one. And as you guys can see, we've just put here 0. So the best way for you to, to arrange this one or to make a frequency distribution is find the lowest and then the highest. So if the incrementation value is not that far, so you can just count everything, like say from 0 up to the highest, which is 7. So you can just count from 0 to 7, and then you can just check this one by one. So 0 has a count of uh, 1, 2, 3, 4, and then 5. So that's why we put here 5. Okay, and then 1 is now, of course, discount how many ones we have in here. 2, discount how many 2 we have in here. until you reach the value of your latest number in here. All right. So that is the quickest way, instead of getting all of the individual datas. So you can just do this one, like ranging from 0 to 7. Just put here 0 for the 6. Okay. So in here, we have to find the mean of data displayed in a frequency distribution. So again, we have this data right here, and then this data right here. So we haven't changed anything. And then this is the solution. So instead of weight, okay, or W for this F right here, so just replace this one into F, since that is the one that we have used. They call this one frequency, okay, instead of weight. Okay, and then instead of summation of W, okay, so this one now is the summation of F. So you could say that this one is the same with the weighted mean. It's just that when we see frequency distribution, this one came from a raw data. So those are the differences and why we have to use F instead of weight. Okay, so just do the math. Okay, so 0 times 5, 1 times 12, 2 times 40, and so on and so forth. And then divided by the total of frequencies that we have here, which is 40. And then you will get 1.975. So there is an average of, let's say, 2 laptops per household. Okay, so I've just rounded this one up since there is no 0.975 laptop. Okay, so it should be a whole number. Let's just say 2 laptops all in all. So are we clear with this one?
Yes, sir.
Okay po, sir.
All right, it's good then. So let's now proceed to the measures of dispersion. So let me just differentiate the difference between the measures of central tendency and then the measures of dispersion. So both of them is the basics or the fundamentals of statistics. So measures of central tendency is central or the center. So let's just say measures of central tendency is equal to average. That's it. Okay, and then measures of dispersion is the it's also the same with average. However, this one is like solving for the error, okay, or the the deviation itself. So this is the main definition of dispersion. Okay, so in here, the lower the dispersion, okay, or the lower the deviation, the better. Okay, so you will see later on what is the use of those, the range, standard deviation, and then the variance. Anyway, let's proceed with the range first. So in the preceding section, we introduced 3 types of average values for a data set: the mean, the median, the mode. So some characteristics of a set of data may not be evident from an examination of averages. So even though we have those 3 types of averages, so there's a chance that we are still missing something. Okay, we can still miss important computations. Like for instance, consider a soft drink dispensing machine that should dispense 8 ounces of your selection into a cup. So we have here the table below shows the data for 2 of these machines. For the machine 1, we have this one, and then for the machine 2, we have this. So let's start with the machine 1 first. So in here we have, let's say it dispense first 9.52 ounces. So it's more than what we expected. So it should be 8 ounces only. The second one is 6.31. So it is now, lacking uh, some amount of soda on that can or in that bottle. The third one is 10.07, so it's more than the average again. So it's more than the expected dispense amount. Okay, and then the next one is 5.81, so we're lacking again. 8.15 is the best one. Okay, I think this is the closest for your 8 ounce. Now, if you guys are going to get the average of those, okay, so you will get a mean of 8.0. So it's like nothing happened, like, okay, we're able to distribute an average of 8.0 for those 5 bottles or for those 5 cups. But if you guys are going to check on this one, some are lacking and then some are just too much. Okay, well, if I'm the customer, so I'm happy if it's more than what I paid for, right? But if you receive this, kind of product, let's say we have 6.41 ounce instead of 8 ounce, so you're not going to start to uh, like maybe what do you call this one? Parang aawayin mo yung tindera. Okay, hindi mo naman sisisihin mismo yung company. But yeah, you're going to ask the store itself, and then me I get a new one. You know, the one that has an exact amount of soda. Okay, which is 8 ounce. So yeah, so we have two defective sodas in here. So what will happen on those two defective sodas? So of course it will put as a BO or bad order. So mga nag-grocery dyan, alam niyo siguro yung BO. So of course, the company itself will change, okay, or will get those BOs and then will be changed by a good product. Okay, like the correct size of, I mean the amount of soda on that bottle. Okay, so malulugi kayo. Okay, so meaning this machine 1 is defective. Okay, so that is the moral lesson of this machine 1, even though we have an average of 8.0. But if you guys are going to take a look on each of those theta, so some are not good or some are defective. But for the machine 2, okay, we have 8.01, 7.99, 7.95, 8.03, and then 8.02. So with this, we cannot argue anymore, okay, with the or with these machines. It's like working perfectly. Okay, so there is actually no perfect machine, so that's why we have some, a little bit of deviation right here, which is 0.01. Still 0.01, it's still lacking 0.01, though the customer won't see that one anymore. Okay, and then this one is lacking 0.05. Again, it's super close. Okay, it's not that obvious. 8.03, so the customer is a little bit more happier since it's more than 0.03 ounce. And then we have here 8.02 ounce. Okay, this is super close with the 8 ounce. And then again, if you guys are going to get the average of this one is still 8.0. Okay, but if you guys are going to check the uh, how it dispenses per cup or per bottle, so this one is the perfect machine. Okay, now if we're going to talk about the range from this defective to the working or non-defective machine. So where is that one? Okay, so here's the summary. I won't be reading everything anymore. So machine 1 is inconsistent, and then machine 2 is consistent. So for the range of a set of data values is the difference between the greatest data value and then the least data value. So here the same like idea. Okay, the lesser the range, the better. Okay, so if we are going to get the range of this one, so latest to highest of machine number 1, so the highest rather, the highest is 10.07, and then the lowest is 5.85. So just do the math, and then it will give us a result of 4.22 ohms. Okay, so meaning this kind of range is a little bit alarming already, since we have this kind of error, okay, which is 4.22 ohms. But okay, so there is no machine 2. But for the machine 2, if you guys are going to get the highest and lowest, probably it's just a point something. So having a range of maybe 1 and below is acceptable. Okay, but having a range of 4 is not acceptable anymore. Okay, so that is how we check the or how that machine performs. Okay, with the use of the range. So are we clear so far regarding with the range? Okay, so in here again, the idea of measures of dispersion is the lower the value, the better. Okay. All right, so let's now proceed to the standard deviation. So in here, the range of a set of data is easy to compute, okay, but it can be deceiving. Okay, so because we are just considering the highest and then the lowest data, okay, which is still, not perfect when it comes to solving the the error, okay, or the ineffectiveness of that machine. So the range is a measure that depends only on two most extreme values, and as such, it is very sensitive. So a measure of dispersion that is less sensitive to extreme values is the standard deviation. Okay, so they made another way of checking the data, in which, even though we've just changed one data, it will affect everything. Unlike in the range, even though we've changed the sum of the data in the middle, it won't make a big change. Okay, well, unless you change the most extreme data and then the most lowest data. So the standard deviation of a set of numerical data makes use of the amount by which each individual data value deviates from the mean of itself. Okay, so this deviation is represented by x minus x bar. So so this one is positive when the data value x is greater than the mean. Well, it's already common sense. And then x minus x bar is of course negative if the other way around is higher. And then if they are just the same, then of course you will get 0, okay, or the same, okay. And in here, the sum of all the divisions of this x minus x bar is 0 for all sets of data. So if it's not 0, then one of your computation is probably incorrect. So this is one way, or the first step for you to check if you made the correct computation or not. So this is shown on the right side table for the machine 2. So we have here the the raw data itself, the first 5, or how it dispense on the battle or the can itself. And then here is the computation for the x minus x bar. So x bar right here is the mean of this one, okay, which is of course 0, okay. And then x right here is just the individual data. So 8.01 minus 8 is 0.01, 7.99 minus 8 is negative 0.01, and so on and so forth. And then if you guys are going to add those, if you're going to add everything, it should be 0. Okay. So in here, you can already check, okay, this one individually. Okay, like this one has a deviation of 0.01, so it's almost perfect, meaning this one is working perfectly. So the same as one, almost perfect. This one is quite far already, 0.05, but it's not that far. Okay, maybe if this one is 0.5 or 0.50, then you might need some adjustment to this machine. But 0.05 is not that much. 0.03 is still good, and then 0.02 is also good. So if you guys are going to do this one the same, with the machine one, so you will get a 4 point something, 3 point something, okay, and so on and so forth. So you will get a higher deviation on that machine one. Anyway, so that's it for the standard deviation. So we have here the formula, okay, like another step. So it didn't end on this part. So this is just the first step. So we have here the standard deviations for populations and then samples. So for the population, we have this one, and then for the sample, we have this one. So both of them are the same, solving its standard deviation. However, if it's population only, so all you need to do is divide that 1 by n. Okay, but if it's sample, okay, all you need to do is divide this 1 by n minus 1. So those are their main differences. Okay, so if it's population, just divide that 1 the count of data that we have. But if it's a sample, divide that 1 by the count of data that we have minus 1. Okay, and then the symbol for population is this 1, and the symbol for sample is s. Okay, and in here, as you guys can see, since we're talking about population, so we should get the symbol of the mean of population, which is mu. Okay, and then for the sample, so the mean of this sample is x bar. Okay, So just do take note of those differences, mu and then x bar, and then n minus 1, and then of course their symbol. All right. So here is now the complete procedure on how to solve the standard deviation of the certain data. So we have 5 steps for this one. So the first one is determine the mean of the n numbers. Second is for each number, calculate the deviation difference between the number and the mean of the numbers. The third one is calculate the square of each deviation and find the sum of these square deviations. The fourth one is if the data is a population, then divide the sum by n. And then if the data is sample, then divide the sum by n minus 1. And then lastly, find the square root of the quotient in step number 4. Now, supposedly, of course, you guys will be memorizing this one if we are only in face-to-face method. Okay, but since we are in ODL, so this will become an open notes. So you guys don't need to memorize this one, just familiarize maybe. Okay, so let's have an example for this one. So find the standard deviation of this sample. So following numbers were obtained by sampling a population. So this one now is obvious. So this one is a sample because this one were obtained by sampling a certain population. And then these are the numbers that he or she have chosen. Okay, 2, 4, 7, 12, and 15. So find the standard deviation of the sample. So step number 1, find the mean. So all you need to do is add everything and then divide how many counts of data that we have. So 40 divided by 5 is equal to 8. Step number 2, for each number, calculate the deviation between the number and the mean. So 2 minus 8 is negative 6, 4 minus 8 is negative 4, and so on and so forth. The third one, it's still part of step 2, okay, we have to add those numbers. So negative 6 plus negative 4 plus negative 1 plus 4 plus 7, it should be equal to 0. Again, if it's not equal to 0, then there is something wrong with your computation. Okay. All right, so the third step, calculate the square of each division in step number 2. So in here, just square this one. Negative 6 squared is 36. Negative 4 squared is 16. And so on and so forth. So all you need to do is square those values. And then get the sum of those. Then we will get 113 as the sum of the squared division. And then step number 4, because we have a sample, so this is now where we need to use this s right here. Okay, s is equal to summation of x minus x bar squared divided by n minus 1. So of course we have to use that formula. Okay, oops, I think I wasn't able to show the computation of that one, but yeah, we have to divide that one by n minus 1. Okay, so in here we have, where is that one? Do I have the computation? So this is the numerator part wherein, after getting uh, or after solving everything on the summation x minus x bar, okay, will give us a result of 118, and then just divide this one by 4, which is now equal to 29.5. Or, okay, or you can just simply get this one. So I think that is the reason why, I just remember, I think that is the reason why I didn't show the competition for this one, because after solving this one, you are like already done with step number 1 to step number 4. Okay, as you guys can see, we've got a 118 and then divided by 4, which is the n minus 1 right here, and then we've got a result of 29.5. And then lastly, step 5, the standard deviation of the sample is s is equal to square root of 29.5. Okay, so this is now the standard deviation, which is 5.43. So it's quite high. Okay, so if this one is only maybe 1 or below, then I think that's already a passing score for a certain machine. Okay, So are we clear with this one so far? So before I required my students to do the two-step, okay, wherein they are going to follow this one, step five, and then they are going to follow this one to solve for the standard deviation. So yeah, that's what I did before. But in here, you're free to use any of those two since they are just the same. Okay, as long as I will be able to get your correct answer with the standard deviation. Okay, so regardless of your ways of solving that one, then it's okay. Okay, as long as your answer is correct. Anyway, so we have another example here wherein, of course, we have to use standard deviation, okay, or we have to identify the standard deviation of this one. Okay, so again, you can use this is step one to step five. Okay, but in here, I think I've shown the other way around, which is the the one-shot formula. This one right here. So we have three companies right here. So in here, they are testing the company that produces batteries that are most consistent, okay, with regard to their expectancy. So consumer group tested a sample of eight size D batteries from each three companies, which is Ever So Bright, Dependable, and then Beacon. The results of this test are shown in the following table. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 tests for each company. So according to this test, which company produces batteries for which the values representing hours of constant use have the smallest standard deviation. So again, in here, the smaller the standard deviation, the better. So all you need to do is apply the formula that were given to you and then just substitute the given values and then you will get those results. So we have here for the ever so bright, which is equal to 1.328 hours. And then we have the dependable, which is 0.719 hours. And then we have here the beacon, which is 0.877 hours. Okay, and again, as usual, the smaller value, the better. So all you need to do is compare those three companies. So just find the lower standard deviation or the lowest rather. So in here, dependable have the smallest standard deviation. So according to these results, the dependable company produces the most consistent batteries with regard to expectancy under constant use. Okay. So of course, you won't be able to see that one if you only have this raw data. So unless you're going to use the formula, and then you'll be able to identify which companies produces the most consistent, uh, long-lasting battery. Okay. So when it comes to checking or verifying this one, so just uh, check this one once our meeting is over. Okay. So we still have 2 minutes and 40 seconds. So I think that is not enough since I have an additional announcement. So I will cut our meeting here for now and then we'll just continue the rest on the part 3. Okay. So goodbye for now and then see you guys later on the part 3.
Bye, sir.
Goodbye. Okay, so hello again, everyone. So let me just check if everybody is already here. So just give me thumbs up. All right, so very good. Most of you are already here. So let's now proceed to the last type of dispersion, which is the variance. Okay, so a statistic known as the variance is also used as a measure of dispersion. So the variance for a given set of data is the square of the standard deviation of the data. So the following charts shows the mathematical notations that are used to denote standard deviations and variances. So we have two types of variance right here. Of course, we have the population and then the sample. And then here are their symbols for the uh, variances for the population and then for the sample. So here we have the symbol for the deviation, and then we have here the symbol for the variance. So if it's population, then you have this one. And if we have, if you're going to solve for the variance, just squared that standard deviation value. Okay, so very easy. So the same example, we have this standard deviation value. Then all you need to do to get the variance is squared this one. Okay, let's proceed now to the example. So find the variance for the sample given example. So find the standard deviation. Okay, so ulitin ko nga, find the variance for this sample given. Okay, on example, find the standard deviation slide 38. Okay, so there should be an on right here. Okay, well anyway, so this is slide 42. So let's just go back to slide 38. So we have here the standard deviation, okay, which is the square root of 29.5, which is 5.43. So all we need to do is square that one. And as you guys can see, the variance is actually equal to the value of our step number 4. Okay, so if you're going to square this one, so you're just simply canceling the square root, and then it will go back to the 29.5 itself. So all in all, if it's requiring you to solve the variance, so all you need to do is, get the value of your step number 4. Well, that is only if you did this one. This is step number 1 to step number 5. But if you are using this one, then all you need to do is squared this standard deviation value. Okay, so are we clear with this one so far?
Yes, sir.
Okay.
Opo, sir.
So anyway, in here I just want to give the gist of what is this variance. So the deviation is the 5.43, right? And then it's acceptable, okay, if it's less than 1. Okay, but in here maybe he is trying to check the average of this after solving this step number 3 is 36, 16, 1, 16, 49, 36, and then the average that you will get is 29.5. So maybe there are some statisticians that are using the value of the variance to get the measure of dispersion. Yeah, anyway, so you can see that the variance is just part of the standard deviation. All right, so that's actually it for the module 5. Okay. So this one is incorrect. I don't know why this one is chapter 4, but yeah, this one is module 5, statistics, because this is a device module. So maybe I wasn't able to change the title. Anyway, so yeah, that's it for the module 5. So any questions so far or clarification? Or if none, so just give me a thumbs up, and then we'll now proceed to my announcement.
Wala na po, sir.
So don't leave yet, because I think this is now your time to shine. All right, so I think there is really no question, so that's good.